Uh, this is chapter number 5, page number 79 of NCERT class 9, paragraph number 3. These examples show that geometry was being developed and applied everywhere in the world, but this was happening in an unsystematic manner. What is interesting about these developments of geometry in the ancient world is that they were passed on from one generation to the next, either orally or through palm leaf messages, or by other ways also. Also, we have found that in some civilizations like Babylonia, geometry remained a very practical oriented discipline, as was in case of India and Rome. The geometry developed by Egyptians mainly consisted of statements of results. There were no general rules of the procedure. In fact, Babylonians and Egyptians used geometry mostly for practical purposes and did very little to develop it as a systematic science. But in civilization like Greece, the emphasis was on the reasoning behind why certain constructions work. The Greeks were interested in establishing the truth of the statement they discovered using deductive reasoning. See the appendix 1. A Greek mathematician Thales is credited with giving the first known proof. This proof was of statement that a circle is bisected, that is cut into two equal parts by its diameter. One of the Thales' most famous pupil was Pythagoras, 572 BC, whom you have heard about. Pythagoras and his group discovered many geometric properties and developed the theory of geometry to a great extent. This process continued till 300 BC. After that time, Euclid, a teacher of mathematics at Alexandria in Egypt, collected all the known work and arranged it in his famous treatise called Elements. He divided the elements into 13 chapters, each called a book. These books influenced the whole world's understanding of geometry for generations to come. In this chapter, we shall discuss Euclid's approach of geometry and shall try to link it with the present day geometry. Now, next point is 5.2, Euclid's definitions, axioms and postulates. Axioms. Axioms, then postulates. The Greek mathematician of Euclid's. The Greek mathematician of Euclid's time thought of geometry as an abstract model of the world in which they lived. The notions of point, line, plane or surface and so on were derived from what we see around them. From studies of the space and solids in the space around them, an abstract geometrical notion of a solid object was developed. A solid has shape, size, position and can be moved from one place to another. Its boundaries are called surfaces. They separate one part of space from another and are said to have no thickness. The boundary of the surface are curves or straight lines. These lines ends in points. Consider the three steps from solid to points. Solid surface line point. One solid is there. This is the solid. So suppose this solid three dimensions of solid has surfaces. One surface, 2, 3, 4, 5, 6. So 2 and 2, and there are 6 surfaces. And every surface has an edge, that is a line, that is side 1, 2, 3, 4, and likewise 4 lines, again 4 lines, 12 lines, and points. So we have 3 lines made by the point. Suppose this line is there, that means many points all together will form a straight line or curved line. You can say a line is a closed collection of points. Each step we use one dimension, is called the dimensions. In each step we lose one extension, also called the dimension. In solid there are 3 dimensions. In surface there are 2 dimensions. In line only 1 dimension, and the point no other dimension. So a solid has a 3 dimensions, surface has 2, a line has 1, and the point has none. Euclid summarized these statements as definitions. He began his exposition by listing 23 definitions in book 1 of the elements. A few of them are given below. Number 1. A point is that which has no part. A point is that which has no part. Second, a line is breathless length. A line is a length but don't have the breadth. So breathless it is. The end of the line are points. So here it is the one end and here it is the second end. So that end is a points. A straight line is a line which lies evenly with the points on itself. Here this is a straight line, so 1 point here, 1 point here, and 1 point here. So a straight line is a line which lies evenly with the points on itself. So many points are there here on this straight line. So all these lines are here evenly, lies evenly. The surface is that which has length and breadth only. The surface, this is the surface. So in this surface only length and breadth are there. This is length and this is the breadth. 6. The edges of a surface are lines. So there are edges, 1 edge, 2 edge, 3 edge, and last 4 edge. So all the 4 edges are lines. And 7. A plane surface is surface which lies evenly with the straight lines on itself. A plane surface is a surface which lies very evenly with a straight line on itself. Suppose this is one line and this is another line. Then again third line, again fourth line, then fifth line. So these are the lines. So this lines makes the break.